finding the vertex of a quadratic function algebraically. At the end of this lesson, you will be able to identify the axis of symmetry and the vertex algebraically. We're going to continue using the axis of symmetry formula and a parabola's symmetric features so that we can find the vertex. The do now says, let's state the equation for the axis of symmetry of the function g of x equals 2x squared plus 4x minus 6. Remember, the axis of symmetry formula is x equals negative b over 2a. So first, let's identify each of our coefficients. A is 2, b is 4, c is negative 6. So now if I use our formula for axis of symmetry, I have x equals the opposite of b over 2 times something. Let's plug in our values. I substitute in 4 for b and 2 for a. We find out x equals negative 4 divided by 4, which simplifies to give us a value of x equals negative 1 for our axis of symmetry. Remember, our axis of symmetry is a vertical line. That is why it's x equals a number equation. Okay, so now our vertex must be on this axis of symmetry because it cuts the parabola in half and our vertex is our turning point. But part B asks us, is the vertex going to be a maximum? Is it going to be at the very top? Or is it a minimum value? Is the turning point at the very bottom? Remember, we can determine this by looking at our A value. A we have listed as a positive 2, meaning A is greater than 0 or positive. And anytime we have a positive A value, our quadratic is always U-shaped, so we end up with our vertex as a minimum. Okay, well, today's goal is to kind of further what we started today in class. We have to find the vertex or the turning point algebraically. So to find the vertex or turning point, we still need the axis of symmetry. The axis of symmetry is always going to slice the parabola in half, and our turning point is on it. So first, we need to get this axis of symmetry so that we can get the x value that we need. Remember, x equals negative b over 2a is used to get this x value. Next, we're going to substitute this value into the quadratic equation. When I substitute x, we substitute x to get y. So now I'm going to evaluate to get the y value. Finally, when we're done, we'll have an x and y value, so we write our vertex as an ordered pair. Let's try it. First, let's identify our a, b, and c values. A is 2, b is 4, c is negative 6. Well, if you noticed, it's actually the same exact function that we were given for our do now. So pause the video, take some time to copy down your axis of symmetry work. Okay, step 1 is complete. We have our axis of symmetry. Same as our do now is x equals negative 1. So for step 1, we're done. Step 2, we're asked to substitute into the quadratic equation. So my quadratic equation this time is g of x equals 2 times x squared plus 4 times x minus 6. But anywhere I see an x, I know I'm going to be substituting in my negative 1, my x value from my axis of symmetry. So if I substitute in negative 1 everywhere for x, I need to carefully evaluate the right side because I'm curious when I input negative 1, what is the output? So when I input negative 1, let's determine the output. Well, for the output, here we would have to follow PEMDAS. So I would have exponents first. We would get 2 times 1, and then 4 times negative 1 becomes negative 4 minus 6. This can get confusing. 2 minus 4 is negative 6. 2 minus 4 is negative 2. Minus 6 more is negative 8. However, if this gets a little confusing with the signs, we can always use our calculator. I just have to type in the entire expression I'm trying to determine. I have 2 times, in parentheses, -1 squared plus 4 times -1 minus 6. Be careful, make sure you use a negative key down underneath the 3, and then use a subtraction sign for the 6. And we end up with the same output I predicted before. So now that I've substituted and evaluated to get that y value, I can express my vertex as an ordered pair. Remember, my vertex always shares the x value at the axis of symmetry, so it's at -1, comma, the output is -8. This is my vertex for our first problem. Let's try this again. We have to state the vertex of this function. So first up, we're going to need our axis of symmetry. So axis of symmetry, x equals -b over 2a. X equals the opposite of b over 2 times a. I can't use the formula if I don't have a, b, and c identified. A in this case is -4, b is 8, and c is 0. So I have the opposite of not really. I have the opposite of b, and b is 8. So I have the opposite of 8, and then 2 times -4 in the bottom. So I end up with x equals -8 divided by -8. Our axis of symmetry here is +1. All right, so we're done getting our x value. We now have to substitute this 1 into the original quadratic equation. So f of x is now f of 1, which is -4 times something squared plus 8 times something. Let's plug in our 1. So we have 1, 1, 1. We're curious, if I input 1, what is the output? So let's determine it. We want to know what -4, and then in parentheses 1 squared plus 8 times 1 will give us. We end up with 4. So if I combine my input, so we've substituted and evaluated, I get my input and my output. My vertex this time is located at 1, 4. Okay. Now for these problems, we are asked to record 3 answers. First, we're asked to state our axis of symmetry on line A, axis of symmetry. And then we are asked to state the coordinates of the vertex. So our vertex will go here and here. And then finally, for each question, we're asked, is the vertex a maximum? Is it at the top? Or is it a minimum at the bottom? So for part C, we're going to have to choose between maximum or minimum. But right now, I'd like you to pause the video, take the time to try the problem on your own, and then press play to check your answers when you're done. Okay, let's check to see how we did. First, we need to determine our axis of symmetry using the formula. Make sure you have your A, B, and C values matching mine. When you evaluate, you end up with the negative of 0 divided by 6. Well, 0 divided by anything is 0. So now we substitute this value, substitute 0, into our original equation so that we can get our y value if I input x as 0. We end up with -2, and we put these together to get our vertex. So first, we can state our axis of symmetry was at x equals 0. Our vertex, which of course is on our axis of symmetry, has an x value of 0, and we find the output has a corresponding y value of -2. Next, we have to determine whether this is going to be a maximum or a minimum. Remember, a maximum means it's at the very top of the curve, a minimum means it's at the very bottom. And we look at the a value to determine this. Because a is positive, we end up knowing, since a is positive, it's a smile, which makes our vertex a minimum value. It is at the bottom of the smile. Okay, next we have our axis of symmetry for the next problem was x equals -3. When we substitute to get our vertex, we find out -3 has a corresponding y value of -4. And then this time again, I have to check my a value. A is positive again, so if it's positive. I have a smile, which means it's at the bottom and it is a minimum value. We are now able to identify the axis of symmetry algebraically using x equals negative b over 2a. And then we can actually use this value to get our vertex algebraically by substituting into the function. Thank you for watching. We'll continue practicing these skills tomorrow.